How can we make a forecast when we have a data with a definite trend? Your data set can be increasing or decreasing like this. When your data set has a definite trend, you can use the linear regression method. So let's talk about the details. First, why is it called linear regression? Why the word linear? We call it linear regression because we use a linear equation to describe the relationship between x and y. What are the examples of a linear equation? For example, is y equal to 5 minus x squared a linear equation? No. For an equation to be linear, the power of each variable should be 1. The power of y is 1, but the power of x is 2. So this is not linear, this is quadratic. How about this? Y equals 4. Is it linear? Yes, it's linear because this means y equals 4 plus 0 times x. The power of y is 1. The power of x is 1. So this is linear. Next, y equals 3 plus 5x. Is it linear? Yes, the power of y is 1. The power of x is 1. So it's linear. So in general, a linear equation has the following form. Y equals a plus bx. X is the independent variable, y is the dependent variable, and a is a constant called the y-intercept, and b is another constant called the slope. So the next question is, how do you determine x and y? Let's take a couple of examples. Suppose in your data set, you have the daily demand for electricity and the daily temperature. So for example, if the daily temperature is 25 degrees, the energy usage per household was 32 kilowatt hours. When the daily temperature was 28, the energy usage was 28. So if your data set looks like this, which one should be x and which one should be y? Remember, y depends on x, so does the energy usage depend on the daily temperature? Yes, that means the energy usage is y, the daily temperature is x. Let's take another example. Let's say you're working at the HR department and you have a data set that shows you how many years of work experience each employee has and how much annual salary each employee makes. And which one should be X and which one should be Y? Remember, Y depends on X, so does the number of years of work experience depend on the annual salary? No. Does the annual salary depend on the number of years of work experience? Yes. So the salary is Y, the number of years of work experience is X. Once we determine X and Y, next we need to determine A and B. So how can we determine A and B? There are a couple of ways to do this. First, use formulas, and next, use Excel. And we're going to focus on the second one. If you're interested in the first approach, you can find these formulas in your textbook. So let's take this example, and I want to show you how to find A and B in Excel. The supply chain manager seeks a better way to forecast the demand for door hinges. He believes the demand is related to advertising expenditures. The following are the sales and advertising data for the past 5 months. So for each month, you have the sales measured in thousands of units and the advertising expenditure, which is measured in thousands of dollars. So in the first month, uh, your company sold 264,000 units, and the advertising expenditure was $2.5 thousand. Now we are at the end of month 5, and we want to make a forecast for month 6. Question A, find the regression equation. So find y equals a plus bx. First, let's determine which one is x and which one is y. Do the sales depend on the advertising expenditure? Yes. So the sales are Y and the advertising expenditure is X. Now, next, how can you find A and B? So let's use Excel. In your Excel spreadsheet, you can enter the sales and advertising, and you can go to data and click on data analysis. If you don't see this data analysis, that means this is your first time you want to use data analysis. So you need to install it. To install this, you need to go to File, go to Options, click on Add-ins, click Go, and select Analysis Toolpack and click OK. And then you'll see this button that says Data Analysis. So click on Data Analysis, scroll down until you find Regression, click OK. The input Y range is this. The input X range is this. And are there labels on your data set? Yes. And where do you want your output? Here. So click OK, and Excel will return 3 tables. So if you go to the third table, you'll see something called the intercept, that's A, and this one is the coefficient of advertising expenditure, that's B. So your regression line is Y equals the intercept negative 8.1 plus 1.9 times X. Now there is another way to find A and B. So you can use built-in functions. For example, to find A, which is the intercept, you can use the built-in function called intercept and select the Y values, comma, and X values. Then this will return the intercept, which is the same as this one. And to find B, you can use the built-in function called the slope and enter the Y values, comma, and the X values, close the parenthesis, hit enter, and you find the slope, which is the coefficient of X. This is the same as this. And here, in the first table, you can find something called R squared. R squared value of this model is 0.96, and this is a very useful quantity. We'll talk about this in more detail later. So let's go back to our question. We found this a regression equation, and next, the company will spend $1,750 next month on advertising for this product. Use linear regression to forecast sales for the next month. So we have this equation, and what value should we plug in for the X value? So that's the advertising expenditure. It's $1,750. But remember, X is measured in thousands of dollars. So X is 1.75. So plug in this number for X, then you find the Y value, which is 183. And you remember this is also measured in thousands of units. So actually this is 183,000 units. Next, let's think about the meaning of the regression line. Which line are we computing? Here we have a plot of our data set. And the linear regression equation is y equals a plus bx, and that's the closest to the data points. So what do you mean by the closest line? How can you measure the closeness between a line and a data set? Let's take a very simple example. Let's compare these two lines. Here we have our data set, and we have two lines, and which one is closer to the data points? Obviously, the first one is closer. By looking at this graph, you can get a sense of which one is closer. But specifically, how can you measure the closeness between the data points and a linear line? We'll use the sum of squared errors. So how can we compute the sum of squared errors? We're going to look at each data point. Let's take the first data point and draw a line vertically until we meet the line. And we measure the distance between the point and the line, and we square this. And this is called the deviation, the residual or error, and we're going to square this error. And we repeat this for the rest of the data points. Go to the second data point, draw a line vertically until we meet the line, and compute the distance. This is called the error, and square the error. And do the same thing for the rest of these data points. And then we're going to add up all the squared errors across all the data points. And that's called the sum of squared errors. And the sum of squared errors will tell you how close a line is to the data points. So the smaller the sum of squared error is, the closer the line is to the data points. So, and the linear regression line is the closest line. So it's the line that has the smallest sum of squared errors. So the regression line, linear regression method finds the line minimizing the sum of squared errors. So it's called the least squares method. I want to make a couple of comments. The first one is the R squared value. It's also called the coefficient of determination. When you run Excel, Excel will report the R squared value in one of the output reports. So what's the meaning of this number? It tells you how well the regression line fits the data points. So you can think of this as the percentage of data points that are explained by the regression line. So for example, let's take this case. All the data points are on the regression line. So what percentage of data points are explained by the regression line? 100%. So the R squared value is 1. Next, the data points are not on the regression line, but they're close to the line. So let's say 50% of the data points are explained by the regression line. So what's the R squared value? 0.5. And next, the data points are all over the place. What percentage of data points are explained by the regression line? 0%. Then the R squared value is 0. Here, next, again, the data points are not on the regression line, but they're close to the line. R squared value is 0.5. And next, all the points are on the regression line. R squared value is 1. So the R squared value is always between 0 and 1, and 1 means X and Y have perfect linear relationship, and 0 means there is no linear relationship. The higher the I squared value is, the stronger the evidence for the linear relationship is. We also call R, the square root of R squared, the coefficient of correlation. Now, the next comment I want to make is about the multiple regression analysis. In the simple regression method, there was only one X value. Y depends on only one factor. But in many cases, Y depends on multiple factors. And in that case, we need to use more than just one X value. For example, if Y depends on 2 factors, we can use 2 independent variables as follows. Y equals A, the intercept, plus B1 X1 plus B2 X2. X1 is the first independent variable and X2 is the second independent variable. And in general, we can have as many independent variables as you need. And this is called the multiple linear regression model. Let's take an example. Let's say you want to predict the average home price in Long Island, and the average home price depends on many factors. It depends on the mortgage rate, the population, and the level of income, and so on. So in that case, we can use the multiple regression equation with 3 independent variables. The mortgage rate can be the first independent variable, the population can be the second independent variable, and the income level the third. So let's take an example. The number of auto accidents, which is Y, in Athens, Ohio, is related to the regional number of registered automobiles measured in thousands, X1, alcoholic beverage sales in 10,000, X2, and rainfall in inches, X3. Furthermore, the regression formula has been calculated as this. Calculate the expected number of automobile accidents under A and B and C. Under A, X1 is given by this, X2 and X3. So to forecast at Y, the number of accidents, you can just plug in these numbers. It's 7.5 plus 3.5 times X1, which is 2, plus 4.5 times X2, which is 3, plus 2.5 times X0, and that equals 28. So that's we can expect 28 car accidents under condition A. For B and C, you can plug in these values.